review of exponent rules as well as some scientific notation. So this first set of problems that there's, I don't know, like 16 or so problems I think, is all about exponent rules. So the biggest thing to remember with exponents is that if I have a normal number as well as variables, that I do different things with normal numbers than I do with these variables that have exponents. So this is actually asking us to do 2 times 1, which is just a 2. But then when we do k cubed times k squared, we have a rule that says to add those exponents. You can also come up with it by writing out what your k's are. This is k cubed and this is k squared, and then thinking about how many k's you have total, which is 5. So either by adding them, 3 plus 2 is 5, or by expanding it, we should end up with k to the 5th power. So our answer is 2k to the 5th power. This 2 does not have an exponent of 3. That would only happen if we had parentheses around the 2 and the k. The 2 itself just has an exponent of 1 and would only change if this number was something other than 1 in front of our other k squared. We have 3p cubed times 4p to the negative 2. So this is where I was saying that this 3 and this 4, which are normal numbers, not exponents, they need to multiply together to get 12, while our exponents for p will need to add together so that we know how many p's we have. So in this case, it's a little harder to expand in some ways because p cubed is p times p times p, but p to the negative 2 is actually telling us about 2 p's that are on the bottom, so that they cancel and leave us with 1p. If we're just using our rules that we know, 3 plus negative 2 gives us 1, so we can write p to the 1st power, or even better, we'd just write 12p because we don't really need the 1st power whenever it happens. So that's our answer. I know that I personally wouldn't count off if somebody left the 1 there, but you might check with your teacher to see if they would count off because we want to make sure not to lose a silly point like that. So on number 3, we've got another rule to look at. So we have x to the 0, and we have to remember that x to, or anything to the 0 power, anything to the 0 power is 1. So this whole thing right here that's to the 0 power ends up being 1. And if there's other things in the problem, then we can really just ignore this completely, because if I have 1 times something else, well, it's still just the times whatever else I have. The only time that that doesn't work is if all you have, like if our problem was just x to the 0, we do have to make sure that we write down 1 instead of either leaving it blank or thinking that our answer is 0. So now we have 3x to the negative 4th. We'd be done if it wasn't for this rule that we have, not rule, instructions. These instructions say your answer should contain only positive exponents. We've got a negative 4, and so the way we get rid of negative exponents is we move whatever that is down to the bottom, because x to the negative 4 on top is really telling us that we have 4 x's on the bottom, so that this turns into 3 over x to the 4th. The 3 doesn't move because 3 has its own exponent, even though it's not written down. It has its own exponent of positive 1. So it gets to stay, but the x moves down to the bottom. So this one is a little trickier, apparently, than I intended. Most people can come up with that r to the 0 is 1, because we just had that on a problem. But then I've had a lot of people be stuck on what to do once you turn that into a 1 with this negative 3rd power. So the way this works is we have a negative exponent, so we'd move it down to the bottom and have 1 to the positive 3rd. 1 to the positive 3rd is just 1 times 1 times 1, which is 1. What we can draw as a conclusion from this is that 1 to any power, even a negative power, should end up being 1. So it should have made sense that 1 to the positive 3rd would be 1, but 1 to the negative 3rd is also 1. A habit that a lot of us have, which is incorrect and will give us wrong answers, is to say that we should change this into negative 3 or even to negative 1. A negative exponent is just telling us to move it down to the bottom before we figure out what it is. The other way to do this is we could have said, well, let me multiply these exponents together. 0 times negative 3 is 0. We'd have r to the 0, and that's still 1. So whatever way you come to the conclusion that it's 1 should be correct, but it's not. It doesn't end up changing into something like negative 3 or even negative 1. on 5. So this is a rule where if I have an exponent inside my parentheses and an exponent out, and we did this on number 4 actually on one of my explanations, we multiply these together. This is saying that I have x squared. The negative is telling us that it should end up being on the bottom, and the 4 is telling us that we have x squared 4 times. And so if we have x squared 4 times, we really have x to the 8th. But the way to work this out, or one of the ways to work this out, is to say 2 times negative 4 is negative 8, and then say, oh, I can't have a negative exponent, so I'm going to move that down to the bottom and end up with 1 over x to the positive 8, which is our answer. Number 6 is a similar kind of problem. We have exponents that need to multiply together. In this case, we're saying we have n to the negative third that we're raising to another negative third. If we multiply those together, we get a positive 9. And since we get a positive 9, it doesn't need to change at all. Our answer is just n to the 9th power. All right, let's make things a little bit more complicated maybe, maybe not. When I have a fraction and I have an n on top and bottom like this, instead of adding the exponents like we did when they were next to each other, we actually can subtract the exponents. That's one of our rules that we have, that if I have a quotient, which we're going to represent with a fraction, we can do negative 3 minus 1, and that tells us the exponent for n, and when we do that, we write it on top at first. Then if it is a negative, we can go ahead and move it down. The 4 doesn't move. This 4 doesn't move because it has its own exponent of 1, but the n to the 4 should end up on bottom. There's another way to do it that some of us might find easier, so I'll explain it. And that's to say, if I have a negative exponent, let's move it first. Let's move the n cubed down to the bottom, and then combine our n's together. N and n cubed together make n to the 4th. And since they're on bottom, we leave them on bottom. The 4 didn't move because it didn't have a negative exponent, but the n cubed moved down, and so what we really had was an n and then 3 more n's for a total of 4 n's. So this would be our answer. There's a lot of problems actually here that end up with multiple ways that you can do it, and so you just have to come up with a way that makes sense to you and then use that way each time. This is a similar problem to the last one, and so we can do it either of those 2 ways, but notice the 3 is to the 1st power, and that's a positive exponent, so no matter what, we should end up with a 3 on top of our fraction, or just we may not end up with a fraction depending on what happens with the p's. So I'll show you the second way I did last time, in case that seems easier if I explain it that way first. That we would move the p's so that they have positive exponents, so the p cubed and the p to the 1st switch places. And then since we still have p's, we would subtract their exponents. 3 minus 1 is 2, and so we get 3p squared. That's not a squared. 3p squared. Now the reason that you might find that easier is because back here, if all we do is subtract our exponents, a lot of us are likely to make a mistake here. If I do negative 1 minus negative 3, I'm really adding 3, and that's how we end up with this positive 2 for our exponent. So either we have to be really careful as we're subtracting, or another way to do it is just to make all of our exponents be positive first, and then to subtract the exponents. Number 9, there's 2 things for us to do here. One is to say, well, k to the 0 is just 1, and in this case, since it's the only thing on top, it would actually maybe be helpful for us to put a 1 up there to remind us that it is still a fraction. And then if we have a negative exponent that's on the bottom, if we move it up to the top, that makes it have a positive exponent. So that's going to end up being k to the 1st over 4. The 4 doesn't move because the 4 has its own exponent, just the k moves up to the top, and that's what gives us the that's what gives us a positive exponent instead of a negative exponent. Okay, let's throw more letters into this, because that's what we do in algebra, is we just add more and more letters. So we're going to treat this as like a 3-step problem. The first thing to decide is what to do with the normal 4 and the normal 3. They're not exponents. So the thing with this is we're allowed to do multiplication in whatever order we want. So we are allowed to say 4 times 3, and then do the x times the x to the 4th, and then do the y squared times y cubed. And so that means that we just need to think of this like normal multiplication, which is 12. This we need to think, oh, I'm going to add their exponents because I have one x and then I have 4 more x's, and that gives me a total of 5 x's. And then here I have 2 y's and then 3 more y's, so that's going to make it be y to the 5th power. So my answer here is 12x to the 5th, y to the 5th. 11. We want to do the numbers in front, -4 and -2 together. Now remember that a -4 and a -2, if we're following our normal multiplication rules, are a +8 because a negative and a negative cancel out. The a's then we multiply together, and so we've got 3 a's and 3 more a's, which gives us a to the 6. One thing that my students have been doing a lot is thinking that having a negative number is not okay because of this rule about positive exponents, and so they think that -4 should move down to the bottom so that it becomes +4, but that's not how it works. You only need to worry about negative exponents, not negative numbers, normal numbers like this, and it's okay for our answer to be negative. And I think that one of these problems that'll end up happening, so you can see exactly what I mean. This one, I believe. So we're going to do -3 times +2, which gives us -6. And then we're going to do x to the -4th and x to the -4th together, which if we add those together are x to the -8. Now we could move those down to the bottom first and then add them together. We could also do that with the y's. But if we just add them and get -4 and then we move them down to the bottom, that's fine too. So either way, our answer overall is negative with a 6 on top, because the -6, its exponent is positive, so it doesn't need to move. We just normally put the negative in front of the whole fraction instead of leaving it on top. So this is -6 over x to the 8th, y to the 4th. And so I was alluding to another way to do it. You could go ahead and say, well, I'm going to move the x and the y down to the bottom on both of these, and that will also end up hopefully giving you the right answer, because then we'd add the 4's together and get 8, and add the 2's together and get 4, because we'd have 8 x's total on bottom and 4 y's total on bottom. So that's our answer. Okay, here, different rule slightly. We want to square everything inside our parentheses. So when I square -2, I'm doing -2 times -2, which gives me a +4. And in fact, a negative inside right here that we're raising to any even power will cancel out. But if I was raising it to an odd power, it would stay. So -2 to the 3rd power would give us -8, and our answer would be negative in front. So I've dealt with the -2, I've squared it. To square the u to the -3, that's where we multiply these exponents together to get u to the -6. As a general way of thinking of it, you should multiply only when there are parentheses. If there aren't any parentheses, we're either adding or subtracting based on if they're next to each other or if they're a fraction. We do need to make this be u to the 6th on the bottom instead of u to the -6th on top. So our answer here is 4 over u to the 6th. And like I said before, we could go ahead and move this, well, I didn't say this before. We could move this down first if we wanted to, and then square it, and we should still end up with a +4 on top. And this is also a rule that the bottom needs to get that squared as well. And so we could come up with the same answer that other way as well. So this is an especially tricky situation because we have a negative exponent. The y to the 0 is just going to go away, and since there are other things inside the parentheses that are not to the 0 power, we don't even need to really worry about that it was there at all. We can just get rid of it completely. So now I need to say what -2 to the -3rd power is, and what x squared to the -3rd power is, which in that case I just need to multiply my exponents. So the way this works is that these both have negative exponents and they both need to move down to the bottom. And so that means we only would have a 1 on top to show it's a fraction. and we would change negative 2 to being to the positive third power and x to being to the positive 6. Once we've done that, then we can figure out what negative 2 cubed is by doing negative 2 times negative 2 times negative 2, which gives us a negative 8. So that means that our answer overall is negative, and on the bottom we have 8x to the 6th. This is something that trips up a lot of my students because they either do negative 2 times negative 3 and get 6, which is not correct because negative 3 is a power. It's not multiplying with this regular number. Or actually a lot of them will say that it's negative 8 on top and then move it down to the bottom and then get rid of the negative, which is also incorrect. So you want to think of it as the negative third power. Know that that means that you move it down to the bottom and then multiply it out so that you get the correct number. 15. We need everything inside to be squared. You can kind of think of this like a distributive property where everything has to get it. A lot of people will forget that even that 4 in the front needs to be squared to get 16. So our answer here should be 16x squared y to the 8th. So since x didn't have an exponent, since we're squaring it, it becomes x squared. Then y to the 4th, when we square it, multiply those exponents and get y to the 8th. On this one, so we have a fraction. We've got a 4 on top and a 3 on bottom. And so we want to think about what we would do if it was just 4 over 3. Well, we wouldn't do anything. You could change it to a decimal, but that's not going to be helpful here. And in general, your math teachers probably at this point and on would rather you not change it to a decimal. So we're going to leave it as a 4 on top and a 3 on bottom, and then decide what else will be on top and bottom based on where our x's and y's are. For instance, an x squared on top and an x to the 4th on bottom means that we'll end up with x squared on bottom. There's a couple different ways we can come up with that. We can do 2 minus 4 and get x to the negative 2, and then know that that needs to move down to the bottom to get a positive exponent. You can also think about it expanded, that we have x times x on top and x times x times x times x on bottom. And so our x's cancel, leaving us with 2 on the bottom. And there may even be more ways that you can think of it, but our x squared should end up on bottom, and then y to the 4th doesn't have another y to change it, so it will stay on top. Here we have a 3 on top and nothing on bottom, and so that 3 is going to just stay on top. If there was, maybe this doesn't happen on any of these problems, which is unfortunate. If we had like a 6 or something on bottom here, then 3 over 6 could simplify, and so we'd change it to a 1 on top and a 2 on bottom. But that didn't happen, unfortunately, so I can't, make that happen now, retroactively. So again, there's two ways of doing this. One is to say, I'm going to subtract the exponents and then decide if they need to move down to the bottom. So 1 minus 4 is negative 3, so x to negative 3 starts off on top and then moves down to the bottom. Negative 3 minus 2 is negative 5, so we start that on top, and then both of these actually need to move down to the bottom, so that it's 3 over x cubed y to the 5th. And that's our answer. This is going to be our last exponent problem, and then the next ones will be scientific notation, which is related. So the 3 halves can't simplify because it's a 3 and a 2. They're not both divisible by something. This y to the 0 can go away. We either need to think that for the x's that we have 2 minus a negative 1, which is really 2 plus 1, which is 3. Or another way of doing it is to say I'm going to move this up to the top, and then x squared and x together make x cubed. And then the y needs to move down to the bottom so that it's y to the positive first on the bottom. You don't have to write the 1 there. It's probably okay if you do write the 1 there, and this would be our answer. And if all along the way here you were thinking, man, can't we simplify further with the different letters? We only simplify when they're the same letter. So a's and a's can go together, b's and b's, but an x and a y can't combine into something else entirely, unfortunately. Or not unfortunately, because that's how math works. But so now we're going to look at scientific notation. So we're going to have problems where we have to take a normal number, which we could call decimal form or standard notation. We're going to take that and change it into scientific notation. Then we'll also look at how to go the other way around. So in order to have something be in scientific notation, we need to change this to a number that's between 1 and 10 by moving the decimal over however many places it takes. So our goal is to get the decimal right here to the right of 5. And so to do that, we need to move the decimal 1, 2, 3, 4 places. So this will be 5 times 10. Now we moved it 4 places to get it over here. And it can be a little tricky remembering whether this means that we have a positive exponent or a negative exponent. So here's how I remember it. 0.0005 is a really small number. Like if you think about measuring something and it being that small, or if you think about if you had that amount of money in your bank account, that would be a really small amount to have. Anytime we're talking about a small number like that, we should end up with a negative exponent, because 10 to the negative 4th is actually 0.0001. And so we're timesing by a decimal number when we times by 10 to the negative 4, and that's how we end up with this 0.000, I may have said too many zeros, 5. So if you have, this would be a decimal number that we're taking to scientific notation. And so we moved our decimal to the right, and that gave us a negative exponent. And the reason I'm writing this down, and I'm going to keep this going for the next few problems, is so that we have something to compare. Because if we're going from decimal to scientific notation, then that's going to be different than when we go from scientific to decimal. And this is the way actually that might seem wrong. We move to the right, and usually when we move things to the right, we would think positive. But no, moving to the right actually means that it's a negative exponent. So now we have a large number. 370,000 is a number I would love to have in my bank account. So this is a large number, which means it's going to end up with a positive exponent. Our goal is to try to get the decimal to be between the 3 and the 7, because 3.7 is between 1 and 10. If we try to put it either in front of the 3 or behind the 7, we will have a number either too big or too small. And so one way to think of that is we just always want one number to the left of our decimal place. So this should be 3.7 times 10, and we just have to count how many places. So 1, 2, 3, 4, 5. I'm actually, especially considering I'm a math teacher, I like to say I'm pretty bad at counting, so I really have to pay attention on these problems personally to make sure that I moved it the right amount. So, and I suggest you also be careful with that. So here we moved the decimal to the left, and that gave us a positive exponent. These are our rules when we're going from normal to scientific. And so then if we were to go the other way from scientific to decimal, then we should be doing the opposite things, because it's like we're converting between two different things. So if you think about when you convert units, if you go one direction, like inches to feet, you do the exact opposite as you would do if you're going from feet to inches. So this time we'll do scientific notation, and we're changing that to decimal notation. And another way of putting it is standard form, which I think is actually what it says on the next set of problems, right? Each number in standard notation. So now, and I feel like this one makes more sense to us, if I have 3.6 and I times it by 10 to the 4th, it's really like I'm timesing by 10,000, because there's 4 zeros. So I'm going to move my decimal to the right 4 places. 1, 2, 3, 4. We can use that trick about big numbers and small numbers again. If it's a positive exponent of 4, we want to make this number look bigger, not smaller. So this would be our answer, 36,000. And we moved to the right because it was a positive exponent. So I'm going to say positive exponent. That meant that we moved to the right. So let's look at another one. So here we start off with 4.4. We're timesing this by what would that be? If it's 10 to the negative 2, that would be like 0.01. So we're making this have more decimal places. So we're going to move it to the left 2 places. So 1, 2, which gives us 0.044. In general, since we should always have one number to the left of our decimal, we should end up, when we're using negative exponents, we should add one less 0 than what this number is. So since this is a 2, even though it's negative, if we think of this like it's a 2, we should have 1 0. If we had times 10 to the negative 10th power, well, you'd have to go one place to get past your number, and then you'd have 9 zeros after that. So that's just if you're, instead of having to like do all of the little spaces and try to count, it's another way to do that. Going the other way, it can be trickier because you might have a lot of numbers on this side, so you have to go past however many numbers you have and then add zeros after that if necessary. Okay, so on that, I already erased it. It was a negative exponent. And so we moved left. So these are our rules. This is what we can use to figure out our problems. Now, that actually is something that we're in an Algebra 1 class right now that we should have done, or probably did in pre-algebra, or maybe in a different science class or something like that. This is where we might end up with something that is unfamiliar to us. So we're multiplying 2 numbers together that are both in scientific notation. One thing that you could do is you could change them both to decimal form and then multiply them and then change them back, because it does say to write your answer in scientific notation. The other way to do it, though, is to use our multiplication rules to our advantage. We can do 5 times 4 first, and then we can think about 10 to the negative 4th times 10 to the 1st, which, using our exponent rules, if this was x to the negative 4th and x to the 1st, we'd add the exponents and get x to the negative 3rd. We're going to do the same thing here, just with a 10. It doesn't change the 10, just like it didn't change it if it was an x, but it does make it be the negative 3rd power whenever we add these together. And we don't need to move this down to the bottom. If you notice in the instructions, there's nothing said about not being able to have negative exponents. So this would be fine if it wasn't for the fact that 20 is too big a number for scientific notation. So we actually need to move this over and make it 2.0 or just 2. Here's the thing that I think is the trickiest part of this, is knowing whether that means that we're going to add 1 to this exponent to get negative 2 or subtract 1 to get negative 4. So if we're using our tricks over here, 20 is in decimal form because it's not in correct scientific notation. We moved to the left, and so since we went decimal and we moved to the left, we have a positive exponent. So in other words, we need to add 1 to what we already have. So that means that this would be 10 to the negative 2. Another way to do it is to take what we originally had and change it to a normal decimal number, and then once we have that, to change it back. Because if I move it 3 this way, when I go back, I'm only moving it 2, so I should get 2 times 10 to the negative 2. As we look at, there's 3 problems like this. As we look at them, you might notice a pattern with them. That's also a helpful way of knowing what to do, is that maybe all 3 of these multiplication problems end up doing the same thing, and then after that we've got division problems, and maybe they do something different than the multiplication problems, but maybe they do the same thing as each other. So in math, and especially when we're studying for a test, we really need to try to concentrate on patterns that we're noticing. That's kind of what math is all about, actually, is finding patterns. So we're going to do the same thing here, just with different numbers. So 4.3 times 9. We may need to do this old school style, where we line everything up to make sure we're right. There's only 1 decimal, so this starts off as 38.7 times 10 to the, we do 3 plus negative 2, which is 1. Well, we need to move this over 1 to 3.87, And so since we made our number smaller, it actually does the opposite of what we probably think it should, and it adds 1 to our exponent. So to go from 38.7 to a smaller number, wow, I didn't write that right, sorry. To go to a smaller number, we actually end up adding to our exponent. So this would be 3.87 times 10 squared. So if you haven't already tried pausing the video and see if you can do this one by yourself, I recommend it. See if you're making progress. We're going to start off by multiplying 2.2 times 9. And that's 19.8 times 10 to the negative 2, because negative 4 plus 2 is negative 2. But we need to move this over 1, and so we need to add 1 to negative 2, which gives us a negative 1. Now we're dividing instead of multiplying, so it's going to be similar as far as how we group things. These numbers we can group together and talk about what they end up being, and these we can group together and talk about them and then write it in scientific notation as a combination of these two things. So if we want to do 1.8 divided by 3, we may need to do some long division, although it doesn't actually take very long. Or we may be able to say, well, 18 divided by 3 I know is 6, so 1.8 divided by 3 should be smaller and should be 0.6. So we should start off with 0.6 times 10 to the, since we're dividing, we actually would subtract the exponents like earlier in the review. But then this isn't proper scientific notation because we actually want the decimal to be on the right side of 6. So notice we just moved that the opposite way as what we were doing with the multiplication. So instead of adding 1 to get negative 6, we need to subtract 1 and get negative 8. So we took a small number and made it bigger, so we had to actually subtract 1 to make that happen. Alright, so this is going to work just like 26 did. We're going to do 6 divided by 3, which couldn't be easier, maybe. And get 2. We're going to subtract these exponents. Be careful when you're subtracting exponents here. It's really easy to want to say that's 0, but negative 4 minus 4 is negative 8. So this should be 2 times 10 to the negative 8. And that one was in proper scientific notation, so we don't have to change it at all, which is super nice. And the moment we've all been waiting for, last problem, we need to do 1.23 divided by 2. And so again, we may need to bust out our skills of division here. Put the decimal up above. 2 doesn't go into 1. 2 does go into 12, so we write down 6 and then do minus 12. That becomes 0. We drop the 3. 2 goes into 3 once, and then we subtract 2 with 1 left over. We bring a 0 down. 2 goes into 10 5 times, so this should be 0.615 to start with. We do 4 minus 1 to get 3, and then we check to see if it's in proper scientific notation, which it's not. So this is 6.15 times 10 to the, we made our number bigger, so it subtracts 1 from our exponent. And on all of these, if we were not sure which way to move the exponent, we could just write them in decimal form and then change them back to scientific notation. We could try a simpler problem to see if we could figure out if that helps. Or we can just try to look back at those problems and see if there's some sort of pattern that maybe all of the multiplication problems did one thing and all the division problems maybe did another. So this is a review of exponent rules and scientific notation for Algebra 1. If you like this video, please hit the thumbs up and feel free to check out other videos. I've suggested one somewhere on the screen. If you want to know when I post new videos, hit the subscribe button, and you can also follow me on Twitter at KSteveMath. If you have a math question that I haven't answered, tweet me a picture and I'll try to answer it. Thanks for watching!